factors, multiples, and prime factors. Now factors, numbers we can multiply together to get another number. For example, 2 and 3 are factors of 6 because 2 times 3 without remainder give the answer 6. A number can have many factors. For example, what are the factors of 12? Let's check what are the factors of 12. 3 and 4. If you multiply 3 times 4, you will get 12. So 3 and 4 are factors of 12. Another factors, 2 times 6 give you 12. So 2 and 6 also factors of 12. And 1 times 12 equals 12. So 1 and 12 are factors of 12 as well. Now, the factors of the number 6 are, first, if we multiply 1 times 6, so we will get 6. And another factors of 6 equals 3 times 2. So, now we can order the factors of 6 in ascending order. 6, the factors of 6 are in ascending order 1, 2, 3, and 6. Now let's take another example. 20. What are the factors of 20? Now let's think about the factors. 1 times 20 equals 20. 2 times 10 equals also 20. And 5 times 4 equals 20. Now, ordering all the factors of 20, 1, 2, 4, 5, 10, and 20. Now, we can find the highest common factor between 6 and 20. Let we order all the factors of 6 and 20 and find the common factors between them. 6, the factors of 6 are 1, 2, 3, and 6. Now 20. The factors of 20, 1, 2, 4, 5, 10, 20. Now, what are the common factors between 6 and 20? So, we have only the factor between them is 2. So 2 is the highest common factor. The highest common factor of 6 and 20 is 2. Multiples. Multiples are really just extended times tables. The multiples of 2 are all the numbers in the 2 times table, such as 2, 4, 6, 8, 10, and so on. Multiples of 2 always end with a 2, 4, 6, 8, or 0. You can tell 2286, for example, is a multiple of 2 because it ends with a number 6. So any even number can divide by 2 and also a multiple of 2. The multiples of 5 are all the numbers in the 5 times table, such as 5, 10, 15, 20 and 25 and so on. Multiples of 5 always end with a 5 or 0. So any number ends with 5 or 0 can divide by 5. You can tell 465 which end by 5 or 460 which is end by 0 are multiples of 5. For example, is a multiple of 5 because it ends with a 5. Multiples according to timetable. So take example, the multiples of 3, which is another name for the timetable of 3. So 3 times 1 equals 3, 3 times 2 equals 6, 3 times 3 equals 9, 3 times 4 equals 12, and 3 times 5 equals 15, 3 times 6 equals 18, and go on. Now take another example, 5. What are the multiples of 5? Multiples of 5 are 5 times 1 equals 5, 5 times 2 equals 10, 5 times 3 equals 15, continue, 5 times 4 equals 20, and go on. Now we can find the LCM, the least common multiple between 5 of 3 and 5. Why? Because we are finding the multiples of 3 and 5, so we can find the LCM of 3 and 5. Again, the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, and go on. 5. What are the multiples of 5? 5, 10, 15, 20, 25, and go on. Now, what is the least common multiple? What is the least? The smallest number which is common multiple between 3 and 5. Let's check. 3, 6, from the multiples of 3, 3, 6, 9, 12, 15, 18, 21. Let's look for the multiples of 5, 5, 10, 15, 20. So we have 15 is a common multiple between 3 and 5. So LCM of 3 and 5 equals to 15. Prime factors. A factor that is a prime number. In other words, any of the prime numbers that can be multiplied to give the original number. For example, the prime factors of 15 are 3 and 5 because 3 times 5 equals 15, and 3 and 5 are prime numbers. Now we have two methods of a prime factorization. The first method is division method and the second method is factor tree method. Prime factors. Prime factors. First, we have the first method is the factor 3 method, or the 3 method. So, what are the prime factors using the 3 method of 28? I will use now the 3 method to find the prime factors of 28. So 28 is a multiplication of 4 and 7. 7 is a prime number, but 4 is not a prime number. It is a composite number. So we will try to take another, from 4 prime numbers. So we will get 2 times 2. So again, what are the prime factors of 28? By using the 3 methods. The prime factors of 28 are 2, 2, and 7. So 28 prime factors are 2 times 2 times 7, which equals to 2 repeating twice, so 2 squared times 7. These are the prime factors of 28. Let's take another example. Find the prime factors of 60. So I will try to find the prime factors by using the 3 methods. 60 is a multiplication between 6 and 10. But 6 and 10 are not prime factors. So we will factorize more 6 and 10. 6 is multiplication of 2 and 3. 10 is a multiplication of 5 and 2. So here 2, 3, 5 and 2 are prime factors of 60. Now 2, 3, 5 and 2 are prime factors of 60. Now 60, the prime factors of 60 are 2 times 2 times 3 times 5. And because 2 repeating twice, so 2 to the power 2 times 3 times 5 are the prime factors of 60. Now let's talk about prime factors by taking the second method. The second method is the division method. The division method is like, now let's take the prime, or find the prime factorization of the number 24. 24 can divisible by the number 2, the number 3 as a prime number, so I will choose 3. 24 divides 3 equals 8. Now 8 can divide by 2 or by 4, but I cannot choose 4 because 4 is not a prime number. I need only the prime numbers, so I will choose only 2. Now 8 divides 2 equals 4. 4 can divide again by 2. 4 divides 2 equals 2. And 2 can divide, is a prime number, can divide only by itself, and 1, the answer is 1. This is the second method of finding